we are at the coast, and we are looking at the landscape of the coast. In our picture, it is shown there. We are saying a coast is a land bordering the sea. And this land does not look the way the land elsewhere looks like. And what are the reasons for shaping it? We talk about wave action. We talk about the sea level changes. Then we also look at what we call coral formation. So let's look at these processes one after the other. Starting with wave action. We start with defining waves, and we say these are ripples which appear on water bodies when disturbed. Waves can be caused by winds, earth movements like volcanicity and earthquakes, movement of large water vessels like the ship, movement of large marine creatures like the sharks, hippopotamus. That's when you see water in a sea or in a lake behaving as if it's moving, it's flowing like it is in a river, yet it's not moving. What is happening there? We have ripples. Those are the waves. So these waves affect the landscape, and they affect them in two forms. One is when they erode, that is wave erosion, and two, when they deposit, when they dump materials, that is wave action. Let's start with wave erosion. And we are saying this wave erosion takes place in four ways. We have abrasion, attrition, hydraulic action, then we have a solution. What happens in these processes? In abrasion, the materials which are being carried by the water or by the waves, we say boulders or big stones. These are the materials which go on or flow along, hitting against the rocks of the coast, thereby damaging them and in the process eroding them. Then attrition, the materials which are being carried, they go on hitting against each other, and in the process they wear down, they reduce in size, and this enables their transportation. Then hydraulic action. In hydraulic action, we have water definitely has air in it, and this air from the water or from the waves is compressed. It enters into the rocks cracks, and this widens the rock cracks. We are looking at the water flowing over the rocks, then the water from the air from the water getting into the rocks cracks, and this brings an effect which eventually wears them down. Remember, we are looking at how waves affect the rock of the coast. Last, there is a solution. This happens where there are rocks which are soluble, which can dissolve, and the main example is limestone rocks. So the water dissolves these rocks through what we are calling chemical action. The water gets into the rocks, and in the process, the rocks are weakened. From there, we move on to the coastal erosion, wave erosion features. We have a list: headlands, caves, stump, and we are going to look at one after the other. The cliff, we are calling it a steep rock face that borders the sea. Then a wave-cut platform, a fairly flat part of the shore formed when a cliff retreats inland. These together are the first landscapes that we are looking at the coast. A steep rock face, those people who can swim, where you can jump from the shore or from the coast into the water. That piece of land which is raised is the one we are calling a cliff. Then below it is a wave-cut platform. In our illustration there, we first of all say notch, that is a simple opening made on the rock face. Then next, definitely there is more undercutting. It continues being eroded downwards, being undercut. So now we say rock almost on top of it. It's like making a shelter. That's what we are calling a hanging rock. The process continues until the rock which was hanging falls into. So when it falls into that steep face is a cliff, and the one which is gently or flat down here is what we are calling a wave cut platform. Interesting. We continue with the wave erosion features. So we are having what we call a cave. You've defined it as a cylindrical tunnel, like chamber extending into the cliff or into the side of a headland. We will be looking at the headland later. An opening. People have lived in caves before. This time we are looking at this happening within the rock face of the rocks at the coast. And you are seeing a small hollow form on a weak area of the cliff. It should be weak. That means it's softer for the waves to carry the parts away. So, and definitely, these areas are certainly to have limestone, which is one of the weaker rock materials. So when they are acted upon through that chemical weathering process of carbonation, we're seeing a cylindrical hole drilled. We're seeing in our illustration there, that grayish part there, getting inside. Then within this very point, we are seeing other features we call blowhole. That is a vertical hole formed on the side of the cliff bordering the land. It is formed when a cave reaches the surface some distance inland as a vertical pit. It is now entering the land. It's entering. Before it was cylindrical, now it is entering. So we have a blowhole there at the rear end there. Then you give that narrow piece of land which is entering. Narrow sea inlet formed when the roof of a cave between the blowhole and the sea collapses. That's what we are calling a gill. Continuing with the wave erosion features. A bay is a piece of seawater jetting into the land or a carved inland of sea. Then a headland is a piece of land jetting into the sea. Bay is a piece of water getting into the landscape. Then headland is a piece of land getting into the sea, as we see in another illustration there. Definitely the headland is at that point where the rock is resistant or is hard. Then the bay is at that point where the piece of land is softy. When it is extensive, that is for the bay, is called a gulf. Our other set of landforms at the coast, which are erosional. We talk about the arch. And we are saying it's an opening from the side of the headland to the other side. So in other words, here we are having a cave eating into the headland. It makes an opening. It makes an opening like we see it in our illustration there. So they can also happen when there are caves that are developed on the either side of the headland. Remember, the headland is that piece of land that protrudes, that enters the sea. Then we have a stack, a pillar of rock left standing on the seaside, formed when continuous wave erosion causes the roof of the arch to collapse. Initially, there was that roof, then it collapses. So that piece of rock left standing in the seaside is what we call a stack, like in our illustration. And lastly, the stack, that the base of the stack left when it collapses as a result of erosion. Continuous erosion acts upon the stack. Then it disappears. So when the tides are low or high, definitely this stack will not be seen. But when the tides are low, the sea level is low, then it can't be seen. It has been a pleasure having you. We love you. Have a nice time.